welcome to the session. So in this particular video, we will talk about amazing interview question which is recently asked in Google company. So what that question says, so this question is based on the array based data structure and somewhat the intuition behind the mathematical concept is also required. So let's get started. Try to understand the problem statement first. So this is about the collinear points. Collinear points. Perfect. So what this question says that, for example, I will be providing you 3 points. So obviously when I'm saying points, you all know that we will be having two axes, x and y. So 3 points are given to you means you will be having something like x1, y1, x2, y2 and x3, y3. Perfect. Now, what you need to tell to me or to the interviewer is that whether these 3 points, which is P1, P2 and P3, whether these 3 points are collinear or not. So you need to tell whether the points P1, P2 and P3, all these points are collinear or not. So basically what do we mean by collinear? Means they are lying on the same line or not. Now you need to understand in our 10th 12th classes we need to have this concept that whenever the points are collinear, at that point of time, can you think of any approach with respect to the slope? I hope you know that the slope of the points will be equal. So if I will try to calculate the slope between the point P1 and the P2, which is equals to M1, is something which is equals to Y2 minus Y1 divided by the value of X2 minus X1. Similarly, if I will try to calculate the slope of P2 and P3, this is something which is equals to M2, which is equals to Y3 minus Y2 divided by the value of X3 minus X2. Now, what I am saying is that the approach number 1 which you can suggest to the interviewer is that if suppose the points are collinear, at that point of time, the value of M1 should be equals to the value of M2. Can I say? If the points are collinear, at that point of time, the value of M1 and the value of M2, the slope 1 and the slope 2 will be equal. This is the very important condition. And if that is happening, means you can say that the given points which is given to me are somewhere collinear, right? And if suppose they are not equal, at that point of time they are not obviously the collinear points. Means what I want to say here is that I want to say the value of y2 minus y1 upon x2 minus x1 is equals to y3 minus y2 upon x3 minus x2. Now I can write the same as I will do the cross multiplication here. So the equation will become, because if you will write like this and try to solve to find out the M1 and the M2 and then you can compare, you might get the exception if the denominator is 0. In order to avoid that exception, what you can do is that you can just try to multiply like this: y2 minus y1 into x3 minus x2, which is equals to x2 minus x1 into y3 minus y2. In this way, you will be able to get a perfect condition in order to have the points to be collinear. This is the approach number 1 which you can suggest to the interviewer. I will obviously try to write the implementation also, whatever I am saying here. But let's first of all try to understand the approaches. What can be the other approach which can be suggested to them? That is approach number 2. Is that if suppose the points are collinear, because 3 points are given to me. So with the 3 points, I can make a triangle, right? With the 3 points, I can easily make a triangle. I hope everyone agrees with me. Now, if the points are collinear, at that point of time, can I say that the area of a triangle is something which is equals to 0? If and only if the points are collinear. And if your area is having some specific value, it indicates that the points are not collinear. What is the area of a triangle, by the way? It is something which is equals to 1 by 2 into the value of x1 multiplied with the value of y2 minus y3 plus the value of x2 into the value of y3 minus y1 plus the value of x3 into the value of y1 minus y2. And this is something which we will be able to get by applying the formula of the area of triangle. And we can just apply the condition that if the area is coming out to be 0, at that point of time I will print that okay, it's a collinear point. Otherwise I can print that it is a non-collinear point. Now what I can do, let me try to do the implementation with these two approaches which we have discussed, right? So here what I can do, I can first of all write the driver code where I can define the points which I want to consider. For example, so here we must have x1, x2, x3, y1, y2 and y3. And now you will be having the points, for example 1, 1, 1, 6, 0 and 9. Now what you want to check is that you want to check, you will call the function which will check for collinear points. Or you can say is collinear points, because it is basically checking that whether the collinear points are, whether the points are collinear or not, right? So here you can pass all the values that you have with respect to the points, which is x1, x2, x3, y1, y2 and y3, right? Now what I can do here is that I can just demonstrate the method definition for the same. So now what I can do, def is collinear points, and inside that I can just type all the points values that we have. Now what I can do is that I can just simply apply the formula. If the value of, what's that formula? If the value of y2 minus y1 into x3 minus x2, so I am just referring this formula only, y2 minus y1 multiplied with, I would say, y2 minus y1 into x3 minus x2, if it is equal to, I think the other one is y3 minus y2, right, into the value of x2 minus x1. If suppose these two things are equal, at that point of time what I can say is that I can simply print yes, given, or you can simply print like given points are collinear. If that is not the case, in else part you can simply print that given points are non-collinear. Correct? Now here if you will observe, what is the value of y2 minus y1? What is the value of y2 minus y1 into x3 minus x2? So x3 minus x2 is something which is equals to 0. So this is 0. What is the value of y3 minus y2, which is 9, into x2 minus x1 is again 0. So 0 is equals to 0. It indicates that the points are collinear. So your answer should be that given points are collinear. So let's see whether we are getting this or not. Yes, we are getting this only. If I will just change the axis like 1, 2, 3, let's see. Now because I have changed the axis, even if you will apply the same formula, you will be able to get that the left hand side, which is the m1's part, left part is not equal to the right part, and that's why the points are collinear here. So here if you will observe, this is the basic approach, I would say approach number 1, where we are trying to find out the collinear points, or we are trying to check the collinear points with the help of the concept of a slope. So using slope concept, we are checking that whether the points are collinear or not. And even if I will talk about the time complexity here, I am not using any kind of a loop, correct? So if I will talk about the time complexity, it is nothing but it's constant. Can I say? Even if I will talk about the space complexity, because I am not using any extra space, it's constant. So just with the help of a slope concept, we will be able to get an idea that whether the points are collinear or non-collinear. Right? Now what's the approach number 2? The approach number 2 is to find out the area of the slope that we have discussed, right? If suppose I will be able to calculate using area of triangle, right? Now, if suppose I will be able to calculate the area, what I can do, I'll just maybe take the same points, perfect, and I'll make it as of now 1 and 1 only. Now what I will do is that instead of using the slope concept, I'll try to calculate the area, which is equals to 0.5 multiplied with what is the value of x1 into what is the value of y2 minus the value of y3 plus what is the value of x2 into the value of y3 minus the value of y1 plus x3 into the value of y1 minus y2. Perfect. So now I will be able to calculate the area. Now I can just make a one check. If suppose the area is equal to 0, at that point of time I can simply print the above statement by saying that the points are collinear. Right? In the else part, I can simply print that the given points are non-collinear. Non-collinear. Now if I'll try to run this code, oops, we're getting some warning here. Let me try to figure it out. What's that? So here we are getting the area value 0.5. Let me try to put multiply here. Yes, now it is fine. So here if you will observe the same thing, because if you will observe here, we are on the same axis. So obviously it belongs to the same line. That's why the points are collinear. If I will further change it by writing like this, 2 and 3, you can try to calculate the area itself. It will not come out to be 0, and that's why the points are collinear. Let me try to go back towards the same point, 1, 1, 1, so that one example you have with the collinear points and one example you have with the non-collinear points. So these are the two basic and well-optimized approaches that you can talk about if someone is asking to you this question in an interview. And let me tell you, this question is asked in Google company. So here, if I'll talk about the time complexity again, so what is the time complexity part? Again, I'm just trying to calculate the area itself. So it will be big O of 1. And similarly, if I'll talk about the space complexity here, again you can say it will be big O of 1 only, because we are not using any sort of extra space. So this is something which I want to talk about in this particular session. I hope that the problem statement is pretty much clear to everyone. If you will observe in order to solve this particular problem, you just require a basic knowledge of mathematical concepts that we have already studied in our 10th and 12th classes. And if someone didn't get the time to get revision, so now I hope you got the revision of those concepts as well. And with this, I would like to end this particular video. I'll see you all in my next upcoming video, where now we will talk about some other different kinds of interview questions which are directly asked from you in an interview. I hope that you are enjoying this series as well. With this, happy learning to all. Bye bye everyone, and I'll see you all in my next upcoming video.